Tectonic shift. Shaping the future with innovation.
Hello everyone, welcome back to Tectonic Shift. In this video, we will compare Docker with virtual machines and will also understand the core differences between them. If you have watched previous episodes of this podcast, you would now know what Docker is and what containers are and why we might want to use it. The problems solved by Docker and containers make sense, hopefully, and it makes sense that we might be looking for a solution like Docker and containers. But if you have been in the software development area for some time, you might also think to yourselves, why Docker and why containers? Isn't that a problem? So that reproducible environment thing, isn't that a problem which we can solve with virtual machines? So machines running on our machines, virtual machines with virtual operating systems encapsulated in their own shell independent from our host operating system, isn't that a solution? Well, kind of. With virtual machines, we have our host operating system, Windows or Mac OS or Linux, and then on top of that, we install the virtual machine. So, a computer inside of our computer, so to say. This virtual machine has its own operating system, the virtual operating system, which runs inside of that virtual machine, let's say Linux. Then in this virtual machine, since it is like a computer, it's just virtually emulated, you could say, but inside of that virtual machine, we can then install extra tools. We can install whatever we want in there because it is just another machine. Even though it is just exists virtually, we can install all the libraries, dependencies, and tools which we need and then also move our source code there. And hence, since it's an encapsulated virtual machine with everything our program needs and all the tools being installed there, we kind of have the same result as with Docker and containers. We have an encapsulated environment where everything is locked in. And we could then have multiple such environments for different projects. Or we could share our virtual machine configuration with the colleague to ensure that we are working in the same environment. Well, this works, but there are a couple of problems. One of the biggest problem is the virtual operating system, and in general, the overhead we have with multiple virtual machines. Every virtual machine is really like a standalone computer and a standalone machine running on top of our machine. And therefore, if we have multiple such machines, especially we have a lot of wasted space and resources because every time a brand new computer has to be set up inside of our machine, and that of course eats up memory, CPU resources, and of course also space on our hard drive. And that really can become a problem if you have more and more virtual machines on your system. Because if you have a lot of things which are always the same and still duplicated, especially the operating system, you might be using Linux in all your virtual machines and still it's installed separately in every machine. And that of course wastes a lot of space. In addition, you might have a lot of other tools installed in every virtual machine as well, which your application doesn't need directly but which still are set up as a default. And that can be a problem as well. So, to sum it up, virtual machines have a couple of pros and cons. They do allow us to create separated environments, and we can have environment specific configurations in them, and we can share and reproduce everything reliably. But we do have this redundant duplication that wasted space. Performance can be bad since we have an extra machine running on top of our host machine, and especially if we have multiple such machines, performance can really degrade. And in addition, even though it is reproducible and shareable, that also can be tricky because if you still have to set up that virtual machine on every system where you want it and you have to then configure it in exactly the same way, there is no single config file you can necessarily share. If you want to deploy your application so from development to production, you also have to ensure that you configure your production machine in the same way as your virtual machine. Alternatively, you run your virtual machine on your production machine, but that wasted performance. That's something you might not want to do in production. So it solves the problem but not in a perfect way. And you might guess that's why we have Docker and containers. And actually, it's really important to understand that containers is the key concept here. Docker is just the de facto standard tool for creating and managing them. So why does Docker help us with that? How do containers solve that problem in a better way than virtual machines do? With containers, we still have our host operating systems, Windows, Mac OS, Linux, whatever it is, but then we don't install a couple of machines in the machine. Instead, we utilize built-in container support which our operating system has or emulated container support. Something Docker will take care about that this works. And then we run a tool called the Docker engine on top of that. And that will all be set up by Docker when we install it, by the way. And then, based on that Docker engine, which now runs on our system, which is just one tool, one lightweight small tool being installed there, we can spin up containers, and these containers contain our code and the crucial tools and runtimes our code needs, like Node.js, for example, but they don't contain a bloated operating system, tons of extra tools, or anything like that. They might have a small operating system layer inside of the container, but even that will be a very lightweight version of an operating system, much smaller than anything you would install in a virtual machine. And you are going to see how containers work exactly and how you create them in upcoming videos under this podcast. Now, the other great thing about containers is that you can configure and describe them with a configuration file, and you can then share that file with others so that they can recreate the containers, or you can also build the containers into something which is called an image, which you need to do anyways, and then you can share that image with others to ensure that everyone's able to launch that same container which you have on your system on their system. And obviously, we are going to dive in detail into images and containers in upcoming episodes of this podcast. So you are going to learn all about that step by step. So if we compare containers to virtual machines, we have a couple of advantages on the container side. They have a low impact on our operating system and machine. They are very fast and they use minimal disk space. Sharing, rebuilding, and redistributing them is very easy because we have these images and these configuration files. And we still have encapsulated apps and environments with everything our app needs, but nothing more, which is perfect, which is exactly what we want. Virtual machines, on the other hand, have that bigger impact on our operating system. They tend to be slower and they also tend to eat up more of our disk space. In addition, as I said, sharing, rebuilding, and redistribution, that all can be done, but also may be trickier than with containers and Dockers. Still, of course, we encapsulate our environments, but we don't just encapsulate our app and what it needs to run, but entire computers. It's like having a totally separate machine, which in rare examples or in rare use cases could be an advantage, but often it's just a bloated thing which you don't necessarily need. Thank you for watching this video. Please comment if you still have any question or doubt regarding Docker versus virtual machine, and stay tuned for upcoming super excited episodes. Until then, bye bye.